All right, I think we'll get started. Thanks for everybody joining today. Welcome to the Future of CAD, Trends and Innovations in 3D Design Technology. As a reminder, all attendees will be muted when you're joining. If you have any questions during the event, feel free to add them in real time in the Q&A section of Zoom or in the chat. We do have staff monitoring for questions. We may actually try to address those questions in the webinar, and if we don't, we'll make sure we have time at the end for a Q&A session where we will try to answer as many questions as possible. As we stand at the forefront of all this technological innovation, the field of CAD is undergoing a real transformational change, and that's basically redefining how we approach design and collaboration. Today, we really face a critical challenge. How do we keep pace with the rapid advancement of CAD technology to not only enhance our capabilities, but also to ensure sustainability and efficiency in our processes? So in this webinar, we'll try to provide some insights on some latest trends and new technologies from AI and machine learning to augmented reality that are integrating into CAD systems and transforming the way that we work. We'll also talk about companies operating on a global scale and how engineers often face challenges with real-time collaboration and the shift to cloud-based CAD, hoping that will address some of the remote engineering collaboration learning, but also it does bring challenges related to data security and internet dependency and maintaining consistencies across the various time zones and cultures. And then third, we'll also talk a little bit about the growing demand for sustainable and eco-friendly products, which puts more pressure on CAD designers to incorporate green design principles into their work. This requires not only a deep understanding of new materials and production processes, but also rethinking of traditional design practices to meet these environmental standards and reduce our ecological footprint on these manufactured products. So my name is Michael Roberts. I'm the Vice President of Sales and Marketing for SPK and Associates, and I'm here with my colleague, Daniela. Feel free to introduce yourself.
Hi, everybody. I'm Daniela. I started with SBK as a CAD engineer, always focused on CAD, PLM, PDM. Now I am a client program manager who works directly with these clients, solving not only CAD problems, but workflow problems, all of the things that we are going to be chatting about in this meeting: how to increase efficiency, how to leverage some of these new technological achievements in a way that improves their company.
Awesome. Thanks. And Daniela is the right one to be here. We literally call her the CAD guru internally. So she's the right one to share some of this with you guys today. So our agenda breaks down like this. In this webinar, we'll kind of talk through what we're calling like AI, machine learning, and augmented reality in CAD. There's some other principles within that, but just high level, that's a really important area with a lot of different technologies. We'll also talk about those eco-friendly principles along with cloud-based CAD, and honestly, some of the pros and cons out of that as well. Not just hey, everybody should go to cloud CAD, because maybe in some instances it's not the right solution. So we'll talk more about that there. And then we'll get into a Q&A session at the end. So Daniela, I really want to start off with the cool stuff first. And I know we want to talk like the challenges and how to overcome them, but just talking some new technologies and what's driving innovation and what folks can expect in the next 10 years or so, specifically around AI, machine learning, and augmented reality and CAD tools. Let's start there.
Sounds good. Let's go for it. So cool new engineering stuff. As a CAD nerd, as Michael mentioned, I've always loved to hear about the newest innovations, right? CAD technology is evolving rapidly, and a lot of this growth is driven by AI, cloud computing, and other technologies that help us enhance design, collaboration, and efficiency. I'll go through these on a high level since we will definitely dig deeper into it. But AI and machine learning really power generative design and predictive modeling. This means you can provide a set of constraints and have a design provided to you that is optimized and applies to those constraints you've set out. Cloud CAD really is great at enabling real-time collaboration and allowing multiple users to work on the same model. To expand on what Michael said about having users in different time zones, uh, this is a game changer in those cases. Advanced simulation also provides instant insights, and we'll definitely talk about how that can be applied. Modern CAD interfaces have also gone through a lot of change. There are experiences that can be helpful for the technical engineer and non-technical staff. We'll definitely cover that. And also sustainability. So that is a very important focus. And some sustainability features leverage AI to have a more appropriate material selection and energy analysis to make sure the designs that are created are eco-friendly, reduce environmental impact, and ensure compliance. Now, with all these advancements, let's jump in. I am excited to get into it. So CAD AI, we see this in the form of generative design. I know AI is the hot topic everywhere. However, in the world of CAD, generative design is still making waves because it pushes innovation. AI-powered tools really help engineers analyze constraints and automatically generate optimized structures, leading to smarter and more efficient designs. On the predictive modeling side, machine learning algorithms can help engineers forecast product performance across different conditions. This greatly impacts reliance on physical prototypes and cutting costs, right? You don't have to go to the 3D print shop, get this prototype printed. It will save you some costs there. By leveraging some of these insights, modern CAD tools enable faster iterations, optimized solutions, and greater product efficiency, which we love to see. uh, so AI and CAD, it's not just necessarily about automation, it's really about unlocking new possibilities in performance and innovation and design. It's very exciting. Um, Perfect. Generative topology optimization. This is a means of creating optimal designs from a set of parameters. I've been hinting at this topic. You can really give the program your constraints like loads, preferred materials, and preferred manufacturing processes, and it will give you an optimized design. This reduces time to market, delivers innovative, differentiated products, which is important when you're going to market, and it reduces product costs. And I will go deeper into the why these are all great things in the next slide. All right, so we touched very briefly on reducing time to market, delivering innovative, differentiated products, and reducing costs. Um, Definitely all why generative design is becoming essential for modern product development. One of the biggest challenges companies face today is reducing time to market. Traditional design processes can be slow and iterative, making it difficult to launch new products quickly. I've been there. You have a change notice. You have to check out the files. You have to make the change. It goes under review. Generative design automates much of this process by creating optimized designs in minutes. Cost reduction is another critical factor, and whenever I talk about these, it all just, it's like a domino effect of, hey, you cut time here, that improves your cost, that improves your time to market. It's really all tied together. With cost reduction, the more time and resources that are spent on iterating and refining designs, the higher the development costs will be. Generative design reduces these expenses by minimizing the need for multiple prototypes and revisions. Now, market competition. Market competition is fierce, and companies are always looking for a way to differentiate themselves. With generative design, manufacturers can explore innovative designs that were previously impossible or difficult to create manually, leading to superior products with better performance. Lastly, something that I think gets overlooked is avoiding over-engineering. Many designs can end up being unnecessarily complex, increasing production costs. Generative design is great for this because it will ensure your products are efficient, lightweight, and optimized for manufacturing. Now, by embracing generative design, companies can improve efficiency, lower costs, and stay ahead in that competitive market. What does this look like? How does this impact both the engineers and the companies themselves? All positive, right? Engineers want to deliver designs that are right the first time and radical design changes and innovation. Uh, by using or leveraging generative design, engineers are able to get it right the first time as this takes their constraints in mind. Engineers also want to deliver the optimal design to meet specific criteria and objectives. With generative design, you can really apply your constraints, right? So it will be right the first time. It will also fit within the scope of your requirements. Companies want to deliver breakthrough innovation, but also have cost reduction in mind and deliver high quality designs that reduce aftermarket cost. All completely feasible with generative design. As you see, it cuts down the cost of development uh, and allows for high quality designs by ensuring that they fit the constraints. Now, what is a tool? An example of a tool that helps achieve this? For all my Creo users out there, there is an extension called Creo GDX. Um, this provides a high performance cloud computing and advanced tool to compare, interrogate, and select the optimal design, right? The program gives you these options, and then it's up to the engineer to select what works best. This really helps drive productivity in more ways than one. For example, an entry-level mechanical engineer can now create a part through generative design without having extensive knowledge of the manufacturing processes that a more senior engineer may have. Generative design will allow engineers to also explore traditional and advanced manufacturing techniques, helping to create more differentiated products. So it does cut down on the design time, but it also empowers new engineers to have a say in that design process. Now let's talk about strategy. Generative design strategy, again, it's focused on AI to automate and optimize product development at every stage. Creo's generative topology optimization allows users to define parameters. As we mentioned, there's geometry, loads, materials, manufacturing processes, and then the system generates the best design automatically. Now, is this only applicable for low volume manufacturing, high volume? It really can be applied to both. For low volume manufacturing, this is something that maybe a business that, for example, is used to prototyping custom products where cost is less of a concern. Generative design allows direct 3D printing of optimized components, which is wonderful. Now, for high volume manufacturing, this is in the case of mass production where cost efficiency is essential. The AI generated design, it can be further defined in Creo to make sure that it is manufacturable at scale. By applying generative design strategies, manufacturers can improve efficiency, reduce waste, and create innovative products faster. Now we're still on the topic of GTO, and I want to jump even deeper. Generative topology optimization in Creo is a powerful tool that ensures optimized structures meet real-world performance requirements. So we just talked about how this would work on a high level. Now, how do we make sure that this design is actually going to be something we want in the real world? We know we can see it on the computer, but will it really pass the test, right? We've seen firsthand how clients benefit from its ability to create high performance, lightweight designs while maintaining strength and reliability. Creo's built-in verification and validation tools help engineers assess key factors like stress and displacement, ensuring each part performs reliably under load before manufacturing. For deeper insights, there's fringe plots that allow users to visualize stress distribution and adjustable legends that make it easy to focus on critical stress points. Engineers can also extract numerical values using probe tools, ensuring precise analysis. Another key feature is the animation of deformation results, which helps engineers see how a structure reacts to applied forces. This makes it easier to spot potential failure points and refine designs before physical testing. Ultimately, GTO and Creo isn't just about generating optimized shapes, right? It's about providing the right validation, simulation, and analysis tools to create safer, more efficient products. Now let's continue on the topic of GTO and explore more insights. Okay, one of the biggest challenges in GTO optimization is converting complex faceted geometry into manufacturable CAD models. Fortunately, Creo streamlines this process while using semi-automated CAD reconstruction, making it easier to transition from an optimized design to a production-ready part. Creo's reconstruction tools convert faceted results into B-rep geometry, which is a method for representing the shape and geometry of a 3D object, eliminating the need for manual work. This ensures that engineers can seamlessly refine generative designs while maintaining structural integrity. This is huge, right? If you've ever been, speaking from experience, if you've ever modified a part and then not realized this part was used in this subassembly and that subassembly, and now these are all broken. Totally not me, by the way. Never did that, right? Yeah, this is just, it spoke to me on many levels. I'm so glad that that is there, that it will refine all these designs. Additionally, Creo's freestyle design capabilities, they really allow for further refinement, right? So you get your design, you can make edits, and you can make them safely and securely. On the topic of generative topology, still, this is a huge topic. It makes the design process as an engineer more interactive and parametric, allowing engineers to really refine and modify those optimized designs, right? We spoke about, well, it will be automatically generated, but you can always modify and make sure that it meets all your cases. Creo takes this a step further by integrating directly into the model tree, which is so seamless. With GDF, which is that generative design feature, optimization results are saved as editable features, enabling engineers to redefine key parameters like geometry, physics, and design criteria at any stage. This is fantastic because at the early design state, there are always changes that need to be made, and it just simplifies that. Automatic change propagation also fantastic. As I said, I've been guilty of editing a part and not realizing that carries downstream. By integrating GTO within Creo, engineers really gain a dynamic, adaptable design process that minimizes the rework, accelerates innovation, and makes generative design more practical for real-life use. So now that we've covered generative design, GTO, quite a bit, I'm going to be switching gears and talking about machine learning. Here we're looking at machine learning in terms of simulation. Simulation is a critical tool for analyzing and validating the performance of 3D virtual prototypes. This aligns really well with generative design, right? You've used generative design to get you the most optimal design. You've modified it to make sure it fits your cases. Now, how can we go about analyzing and validating? Whether it's structural, thermal, or vibration analysis, simulation helps engineers predict real-world behavior before manufacturing begins. So there are a plethora of popular tools like SolidWorks Simulation, ANSYS, and Creo Simulate that provide powerful capabilities to test designs under various conditions. By integrating simulation early on in the design process, companies can lower life cycle costs, reduce time to market, and really drive innovation. Most importantly, simulation helps prevent costly late-stage errors, reducing the need for rework while ensuring high product quality. Incorporating simulation into CAD workflows leads to smarter, faster, more efficient engineering, making it an essential part of product design. So with that being said, we're going to jump into one such program called Creo Simulate. Let's explore that. So one of the powerful features in Creo Simulate is really the ability to tailor to what you need. Do you need static analysis? Do you need dynamic analysis, thermal? It's important to note that thermal is not a CFD tool or a computational fluid dynamic tool, so it doesn't automatically calculate these conditions. Uh, However, engineers are able to input thermal parameters to evaluate how heat affects the design. Once the temperature fields are analyzed, they can be seamlessly integrated into the structure, allowing engineers to calculate thermal displacements and stresses for a more complete structural assessment. So here's an overall look of what Simulate can do, and it really allows engineers to better understand performance and structural behavior, leading to more reliable and optimized designs. Still chatting about Creo Simulate, right? This is such a great tool, and a lot of the companies we work with use simulation. It truly allows engineers to make smarter design decisions. It reduces costs and allows companies to bring better products to market faster. One of the biggest advantages here is the ability to detect and correct design flaws early on, preventing costly rework, right? That is always something that adds to the cost of product development. With continuous analysis, engineers can optimize integrity, function, performance, and cost throughout the design process. Creo Simulate allows teams to quickly assess stress, thermal, and dynamic loads, ensuring product reliability. And also by leveraging virtual testing, companies can reduce their dependence on physical prototypes, leading to faster design cycles, lower material costs, and improved efficiency. Lastly, Creo Simulate plays a role in risk mitigation. So we're able to identify those failure points early and use that to enhance product durability, minimizing warranty claims and liability concerns. Overall, by integrating simulation into your workflow, engineers can design with confidence. You can cut costs and accelerate innovation. All right, now that we have covered generative design, we've covered machine learning in the form of simulation, we're going to jump into AR. AR is a technology that is reshaping the way engineers design, validate, and communicate complex CAD models. So when you think of AR, you may think of it as a visualization tool, right? Something that communicates a product or an idea. Companies adopting AR, however, do see faster development cycles, reduce costs, and improve collaborations. And what does this mean in practice, right? How does this translate into the company sphere? AR really allows non-technical stakeholders to interact with product data, provide feedback, and collaborate in real time. This makes it easier to publish, share, and refine designs before manufacturing begins. Software companies recognize AR's potential in the CAD world. For example, PTC has integrated AR into Creo Essentials and Creo Engineer packages, making these tools more accessible. I feel like when I thought about AR in the past, it always seemed like something you'd have to really opt for the deluxe package, right? You'd have to really get this license. And Creo is making that much more accessible. Still on the topic of AR, I have to mention non-technical stakeholders, vendors, and even marketing, right? One of the biggest challenges in collaboration is preparing and sharing CAD models for review. Traditional methods involve pretty tedious file exports, version control issues, and manual distribution. Again, I can relate. Whoever has had to take a model and create a zip folder and send it off into an email with hopes it gets received and opened can relate, right? Is it the latest version? Does your end user have the appropriate program to view? What if they get errors when they open? What if this isn't what they're looking for? What if all these questions, right? When you are sharing data like this, especially to non-technical stakeholders who may not have Creo or PTC installed. Creo AR is changing the way that engineers and teams interact with these models by allowing users to create and share immersive AR experiences without the complex file preparation. I know I've received requests from marketing teams asking for a model or a visual of a model, and trying to do that can be pretty tricky. I'm trying to find the angle that they want, the product that they want, make sure it's the latest version. How do I send it over to them? They don't have SolidWorks. Can I do a screenshot? Oh, okay, I've been there. So instead of sending these static CAD files, designers can publish interactive AR models that teams can access and review in real time, no matter where they are. So this means that engineers can gather feedback faster, iterate more efficiently, and securely share critical product data without exposing proprietary files. This leads me to vendors. There's often times where we need to work with a vendor. I've seen STEP and IGS files used because of the limited geometry, but how great would it be to have an AR model you can share? By integrating AR into the CAD workflow, companies can reduce the miscommunication, accelerate decision making, and bring products to market faster. AR isn't just a visualization tool, it's more of a collaborative advantage that transforms how teams interact with their designs. Now, delving into this a bit deeper, another challenge in engineering and product development is accurately conveying the size, scale, and real-world functionality. Traditional 2D drawings and static CAD models, even physical prototypes, can fall short in demonstrating how a product fits into its intended environment. Creo AR solves this by allowing engineers to place full-scale, interactive 3D models into real-world settings. Whether it's a massive construction machine, as you can see here, or a precision engineered component, AR enables teams to visualize functionality and context. With AR, teams can explore designs from every angle, interact with product features, and even simulate operations, all without the cost and limitations of physical prototypes. Beyond engineering, AR also enhances customer engagement, turning static presentations into immersive, true-to-scale experiences, right? How great would it be to see the AR version of your model rather than that 2D screenshot? Ultimately, AR is not just that visualization tool, it's a game changer for validation and communication. Now that we've covered quite a bit here, we've covered generative design, simulation, we also have covered AR, we're jumping into eco-friendly design principles. Sustainability is now a core in product design. Let's check out why. CAD tools are now constantly evolving to support sustainable design engineering. Platforms like Dassault's 3D Experience integrate lifecycle assessment tools, allowing engineers to evaluate the carbon footprint, material impact, and recyclability directly within the design environment. In addition, Creo's real-time sustainability analysis is now helping engineers compare materials, assess energy consumption, and optimize for lightweight design, all while maintaining performance. These tools empower engineers to make data-driven, sustainable decisions early in the design process, reducing waste, cutting costs, and ensuring compliance with environmental standards. The future of CAD isn't just about the most optimized design and efficiency, it's also about designing for a better and more sustainable planet. A case study I wanted to delve into is Cummins. At Cummins, advanced tools like Creo Generative Topology Optimization, Creo Simulate, and Creo Simulation Live are revolutionizing their design process. So we've just chatted about all these tools. Here is a real-world example. By creating and testing digital prototypes, they can predict how their parts will perform in real-world engine systems before physical models are even made. Creo Simulation Live offers real-time feedback, enabling faster iterations and more design options, all within the CAD environment. This quick analysis helps ensure designs are functionally correct from the start, eliminating the need for back and forth with analysts and speeding up time to market. Additionally, Cummins is investing in additive manufacturing to reduce part count and create complex features that are not possible with traditional methods. By focusing on materials like stainless steel and Inconel, they balance cost and performance. These technologies are helping humans create better, more efficient products while cutting costs and accelerating innovation. Now, we also have a different case study from Lawrence Livermore National Laboratory. PTC helped them make a groundbreaking scientific achievement possible, harnessing nuclear fusion for clean energy. Using Creo and Windchill, engineers designed a machine to support a highly complex experiment, managing over 3.5 million parts. That's more than the number of parts in 100 cars. As someone who's been around CAD and who is an admin for PDM vaults, I had to stop at 3.5 million parts. That is a lot. Lawrence Livermore's challenge was immense, right? I'm still stuck on the 3.5 million parts. They needed to precisely channel 192 powerful lasers to a single fuel pellet, requiring incredible accuracy. Creo provided the precision needed, while Windchill enabled seamless collaboration between physicists and engineers, managing product design and data at scale. The result was that Lawrence Livermore successfully designed the world's first clean energy fusion reactor, proving the power of Creo and Windchill working together. This collaboration underscores PTC's digital thread strategy, helping customers innovate faster and reduce friction in their design process. Again, this is just a great example of using CAD and using all the tools out there now to complete incredible projects.
So no more excuses of we have too many parts for Creo to handle, right? Like that's not an argument anymore.
I'm still in shock, Michael. The 3.5 mil, I will never complain again about not being able to find a screw. No, no more.
Well,
Oh,
let's pivot onto the cloud CAD side. There are some technologies out there, and Danielle, if you want to walk through a little bit of some of the benefits, and then we'll talk about some of those tools.
sure. So CAD and the cloud benefits, I'll go over these fairly quickly as we will delve into them deeper. There's the lower total cost of ownership, secure and scalable. Scalable is something we've definitely seen. Accelerates the innovation, simple user access and entitlement control, push button or automatic enterprise updates. I've also seen this, and this is beautiful. I just received an email the other day that a company who uses 3D Experience, their platform was updated overnight. Did not need any insight from me, no oversight. It was wonderful. Um, Multi-user, real-time concurrent design. I think we touched on this topic at the beginning of the webinar here, where you can have two users working on the same model. Design branching and merging. It's also simple to deploy and it easily integrated with cloud-based PDM or PLM solution. Now here is our review on one of these platforms. There are two big ones out there, among others. That's Dassault's 3D Experience. Some of the pros of 3D Experience are an integrated design environment. This is all in one on your browser. Cloud-based access that makes it very easy to access no matter where you are. Advanced simulation capabilities, this is also a big one because a lot of these programs require significant amounts of resources in terms of hardware. Data management and lifecycle management, you automatically have this, as well as customization options, just like you would on a desktop version, and collaboration tools. Now, some of the cons or things to consider when looking at 3D Experience or similar platforms is the complexity and learning curve. I use this platform as well, and it took a bit of learning. It really did. The cost, performance issues as well as integration with some legacy systems. That can definitely be something to consider. And finally, vendor lock-in. You are essentially all Dassault here, which is great, but it's something that you should take into consideration, especially if you are a company with different CAD platforms, right? There are folks who really are all about PTC and all about SolidWorks or vice versa, that would really lock you into one environment with one vendor. All right, and next we'll be looking at Creo Plus. So generally Creo Plus is very similar. Um, it does have the simple user access and entitlement control, as well as the push button or automatic enterprise updates. In addition, the traditional updates, there's real-time concurrent design solution, and Creo Plus also offers the ability to do design branching and merging. Um, there is also the same con here of vendor lock-in. Maybe you're a company who has different divisions and each one uses a different CAD. We've seen it all. You were really locked into, hey, PTC, you're using that for PDM, PLM, drafting. That may be a good thing, or you may want to take that under consideration. Now, SBK VCAD, this is a fun topic for me and all of us as well. SBK VCAD is a solution we created during the pandemic when engineers couldn't get to their powerful workstations because the office was closed. SBK VCAD is a cloud-based platform that enables you to use other traditional MCAD, ECAD, FEA applications like SolidWorks, Creo, ANSYS, and others. It is a secure, scalable, cloud-based CAD environment, and it really enables engineers to access a high-performance CAD workstation from anywhere, eliminating the need for expensive local hardware. I just mentioned, hey, simulation that takes a bit of resources. This is a great answer. SBK VCAD is also optimized for performance and collaboration because of its high performance cloud GPU and computing power that is tailored for CAD workloads. VCAD instances, this is one of my personal favorites, can be shared with other engineers at the same time for seamless team collaborations. We've tested it extensively on non-optimal network environments, and SBK VCAD is optimized for a low latency remote access and ensures a desktop-like experience. From my point of view, I love helping CAD users on VCAD because I can access their machine quickly. I don't have to send them a remote session link. I just log in and I can see exactly what they're doing and help them out. It's magical in that sense. I can imagine it would be similar to use for collaborating with a team member. Compliance is also important for our clients. That's why SBK VCAD is backed by our SOC 2 certification. And because of the way we have built SBK VCAD, there is no risk of CAD files being stored on unmanaged devices. We see this quite a bit from various clients. Hey, I have a new computer, but my files were checked out on the old computer. Where's the old computer? No worries about that. It really simplifies IT as well because the capital expenses on workstations are diminished. Engineers can scale up or down based on projects or personal needs, which reduces idle resources. And yes, it still connects to your existing PLM or PDM systems, as well as supporting hybrid and fully cloud-based workflows. Let's talk a little bit more about SBK VCAD. If you'd like to see SBK VCAD in action, please scan this code or visit the web address at the top of the screen. And you can see YouTube videos of me walking through the basics of VCAD instances, such as creating them, shutting them down, deleting them. What's really great about this is that you can open up your VCAD machine. Let's say you have something else. You have a meeting, design review, you've left your computer. It will shut down after going idle, which is really nice. But you'll see all that in the YouTube video.
All right, Daniela, we need to get to the automation component, which obviously that's one of the other future trends that we wanted to talk about. So cloud CAD, and now we've got to figure out how to automate all this stuff so that the AI can do all the work and our engineers can go get coffee every day and they don't have to worry about doing any design now, right? Is that the is that the goal here to automate everything?
No, I would say use it as a tool, right? And
Cool.
the
Okay,
engineer
got it.
still needs to validate, verify. Use
Got
it
it.
as a tool.
Do you like this this digital transformation component that PTC had put together? So I'll let you talk through this.
Sure. Thanks, Michael. I really like this slide because it connects all aspects of product development from CAD, PLM, ALM to IoT. It really shows how an integrated ecosystem enables real-time collaboration, automation, and just better design making across teams instead of having these silos that can pop up. For smaller companies, building a tech stack is easier as they expand, but for large enterprises, as we've seen, system integration is more complex due to the mix of tools from vendors. I know I touched on, hey, if you're going to 3D Experience, if you're going to Creo Plus, you're going to be more locked down to that one vendor. Uh, it is important to note with PTC Suite, Creo for CAD, Windchill for PLM, Codebeamer for ALM, and ThingWorks for IoT, these systems work seamlessly. So I wanted to give a balanced perspective of maybe you don't want to go with one vendor, but if you do, there are solutions for every aspect of your product development workflow. The alignment can reduce errors, improve collaboration, and enable advanced automation through the product lifecycle process. So it is something to consider, especially if you're a newer company that's ramping up and looking at weighing your options right between what tools to use. I wanted to share this to make sure I give the other side of going into a vendor specific tool. Now touching a bit on Creo and automation, Creo and the digital thread. Creo plays a crucial role in the CAD component of the digital thread, helping engineers streamline product development. With Creo, teams can work concurrently across all departments, all referencing a single source of truth for design. When a design change is made, associated deliverables like drawings, analysis models, and manufacturing sequences will be automatically updated to reflect that change. This concurrent workflow promotes early involvement from the product and solution specialists, allowing them to provide valuable insights that enhance product quality, reduce the tooling costs, and improve manufacturability. Identifying issues early in the process ensures changes can be made at the lowest cost and effort, preventing costly late-stage revisions. Again, this all ties into the accelerated time to market, reduced costs side of things that we've been discussing.
Thank you, Daniela. This was awesome. There was a lot of really good stuff in this webinar, and we'll get ready for our Q&A. But let's wrap up and do some small housekeeping things. Hopefully, you did get to get some value out of today's webinar where we talked about generative design, simulation, and augmented reality. Danielle talked about the importance of eco-friendly principles in that future design, which is an important part of what engineers are going to have to deal with, along with the cloud CAD component. And I know there are some options. There's some challenges with network latency has been the big pushback from many of the engineers we've talked to, but there are options out there, and even SBK VCAD was one that does help solidify some of that latency concern. And also, I think we got through some of the basic challenges of what engineers have to deal with and how the future options should help support them going forward. Just a quick update for those of you who may not know who SBK and Associates are. We're a woman-owned business. We've been in business for over 22 years. We're based in the Bay Area in California. And we work with a lot of different technologies. Obviously, we mentioned PTC and SolidWorks and 3D Experience and whatnot here, along with some other tools. But we're also partners with Atlassian, GitLab, Master Control, and a bunch of other technologies as well. In terms of partnerships, as I mentioned, PTC partner, but we partner with a lot of different technologies, and we try to align our clients to not only best practices, but best-in-class tools that support their needs. And so we obviously have a robust network of partners that are committed to leveraging their technology and our services to support their best desired outcomes. I want to touch quickly on SPK ACEs, which actually stands for the four components ACEE. So there's two E's in this ACEs. Accelerating the time to market, which is really what this webinar is about, and is a number one priority of us when we work with our customers. Cost efficiency, ensuring we're reducing costs and cost control, aligning with compliance as well, and then providing our customers with or helping our customers produce an exceptional quality in their product. So everything that we do really should align to these four principles. That's really what our day-to-day is about, is aligning to those. So let's turn to our Q&A section. See if we have okay. No questions at the moment. If anybody has any questions, feel free to throw them in the chat or the Q&A section. Okay, we got one here, Daniela. What skills do engineers need to effectively use these new technologies like simulation, and simulation not new, but if it's new to you, simulation and generative design?
That's a great question. So definitely familiarity with the CAD platform. At this moment, there's dozens of trainings that can be completed if you're not 100% comfortable with simulation. I would say it takes a learning curve. So I definitely recommend pursuing training, whether it's PTC, university, Solid Professor, or a variety of other tools. I know Linda for LinkedIn. There's, of course, a plethora of YouTube videos, but familiarity with the CAD platform is a wonderful base layer for learning some of these additional tools.
And we got another one. Do you feel that augmented reality can replace traditional CAD systems?
I think we briefly touched on this. So I don't think that augmented reality can fully replace traditional CAD systems at this time. I do think it's a wonderful tool, just like generative design and using some of the AI capabilities. I think it's a wonderful tool to leverage. I am of the mindset that there should be an engineer there validating and checking each design. So I think it's a wonderful tool. Do I think currently it's taking away from traditional systems? Not at this time.
Okay. Perusing our Q&A section. Don't see any others at the moment. All right, if we don't have any more, we will go ahead and end this webinar. Daniela, thank you for your time. Really appreciate your time and attention here today, and all the things you've educated our attendees on. Be sure to connect with us on LinkedIn, or both Daniela and my email are also listed on the screen. Our team will make sure that you have a recording definitely within 10 business days of this webinar, if not before. Usually we're a lot better at than 10 days, but I guarantee at 10 days we'll have something in your inbox. So if you were able to attend, but your teammates weren't, and you'd like to share that with them, feel free. And for those that weren't able to attend live, you'll have the recording in your inbox. All right. Thanks everybody for joining, and we'll see you next time.